look at the concept of force. Every day we talk about force and we experience force, but we never define force. It's natural that the definition is not that easy. Many times defining things are difficult. But let us define force, understand about some things about the force. Force, in very simple terms, is just a push or pull on the object. If I have an object and if I start pushing an object or pulling an object, so then I will say that the force is being applied on the object. So in simple terms, force is a push or pull. So as you have realized it, force comes into picture when there is an interaction between the bodies. For example, if I am there and then I am trying to lift this, and then I can say that a force is being applied on this marker, and I would say there is an interaction between my hand and the marker. So whenever there is an interaction between the two bodies, then the force comes into picture. That interaction could be sometimes physical, that means we can see, sometimes we cannot see, and non-physical. So the interaction could be due to physical contact or it could be because of the non-physical contact. Next we will see what are the effects of force. Fine, force will be applied on a body day in and day out, every day. Every body is being acted upon by many number of forces. Even now as I am talking, I am being pulled by the gravitational force. So every body in this universe keeps on being acted upon by forces. That forces could be one or many. Let's see what is the effect of this force because of the application. The first, there are two broad categories of effects. One, the force could either change the state of motion or it could change the size and shape of the body. For example, if the body is a rigid body, as we have defined in the earlier class, the body is a rigid body, and then when we apply a force on it, then that force could only do a change in state of motion. What do I mean by change in state of motion? Change in state of motion simply means its velocity, acceleration, and the position. These are the various parameters which will describe the motion, and these parameters will change. Simply when I say it will change the state of motion, all that I mean is, if the body is stationary, then the body starts moving. That movement could be translational or rotational, depending upon whether it is a free body or a pivoted body. If it is a free body, translational, and a pivoted body, rotational. Or if the body is already moving and then a force is applied on it, then the body simply accelerates. So a force, if it is applied on a rigid body, then it will change the state of motion. That means either it will set the body into a motion, or if the body is already in motion, then it will accelerate. If the body is non-rigid, as we have described in the previous class, all bodies are not rigid. In fact, a rigid body is only an ideal body. There is in reality, the bodies are not rigid. So if the force is applied on a non-rigid body, then what is the effect? The effect is two things. It will change the shape and the size. So the shape and size of the body will be changed. That is called simply deformation. So the body deforms. We might have seen many times, if you take a rubber band and then when you stretch it, then all that happens is the rubber band increases in length. So that is called a change in size. And if you take probably a balloon and then if you apply a force on it, then it would change its shape and it would become maybe deformed or squeezed. So that's called a change in shape. So the change in shape and size will happen when the force is applied on a non-rigid body. So what are the types of forces that we have? Majorly the forces are two types, depending upon whether the force is, whether there is an interaction between the two bodies or not. If there is an interaction between the two bodies, then the force is called a contact force. For example, a physical contact will be there, and a frictional force is called a contact force. So whenever you have a floor, on the floor if you have a body, and then if you are moving, so the frictional force acts opposite to the applied force. And then as you see here, there is an interaction or a physical contact between the body and the floor. That is why there is a frictional force. So the frictional force is an example of contact force. Whereas non-contact force, apparently we do not see any contact between the two bodies, but still the force is being applied. For example, if you see magnetic force, if you place an iron nail near a magnet, the iron nail will be attracted towards the magnet. Is there any physical contact between the two? Obviously no. But even then, there is a force. That force is called magnetic force. Similarly, when we see electrostatic force, and then some objects, for example, if you have pieces of paper and they're on a comb, you might have experienced that when you place the comb after rubbing against your hair, and then when you place it near the pieces of paper, the pieces of paper gets attracted to the comb. That is because of the electrostatics. The static charges that are developed on the comb will attract the paper. So that force, again we see we don't have to really touch the paper so that the comb attracts them. Even there is a distance, the paper pieces gets attracted to the comb. It is because of the electrostatic force, and that force is, again, there is no contact between the comb and the paper pieces, so it's a non-contact force. Similarly, gravitational forces, I don't even have to be in contact with the earth to experience the gravitational pull. So gravitational force is also a non-contact force. So depending upon whether there is a contact between the two bodies or not, we can define the forces into contact and non-contact forces.